Hi everyone, hope you're doing great. Just wanted to bring you a quick video about how we can describe a gas. So as you know, we are in our gas laws unit and we have learned about the kinetic molecular theory so far. Now we need to move towards kind of making some more math-based calculations related to gases. So it turns out when scientists describe a gas, they use four different properties typically to describe that gas. They use the amount, which we represent with the lowercase n. They describe the volume, which we represent with the capital V, the temperature, which we represent with a capital T, and the pressure, which we represent with a capital P. So we're going to go ahead and talk about those four properties today. Let's go ahead and get right into it. I'm just going to switch colors here. We can start right now with amount. And like I said, we describe amount, or we use the variable lowercase n to describe the amount of a gas. We're not going to use a capital N because a capital N actually is a variable that is for Avogadro's number, which of course is 6.02 times 10 to the 23rd. And we don't need that right now. So we're going to use the lowercase n. And amount is basically the moles of gas present. So amount, when we talk about gases, is always going to be measured in moles. And so that means if you are given grams, you're going to go ahead and convert it to moles. Having trouble with my pen here, moles. If you were given number of particles, you would go ahead and convert it to moles. So when we talk about the amount of gas, we always want to talk about the moles of gas. So let me give you a quick example. For example, if I had 24.02 grams of oxygen gas, okay, I would convert that by using the molar mass from the periodic table. Oxygen is 32 to moles, and I would get an answer here, and that answer would be in moles of oxygen. So I'm just pulling out my calculator here. 24.02 times 1 divided by 32, and I got 0.75, so I'm going to call that 0.8 moles of oxygen. And so that means in this case, N equals 0.8 moles. Okay, so when we talk about gases, we're always going to measure the amount in moles. Again, if I was given number of particles, I would use my mole map and I would convert that to moles. So that would look something like this. Let's say I had 2.8 times 10 to the 24th molecules of CH4. I would just need to quickly convert that by using 6.02 times 10 to the 23rd molecules CH4. And we reviewed that before we left for distance learning, so hopefully you guys remember how to do those mole problems. And so then in this case, N would equal, just going to plug that in. Remember, I'm using that EE button, 2.8 E24 times 1 divided by 6.02 E23. And I get N equals 4.7 moles. Okay, awesome. So the first way we describe a gas is by its amount, which we represent with a letter N. Okay, the next way we describe a gas is we describe its volume, which we represent with the capital V. Lowercase v stands for velocity in science, so we don't want to use a lowercase v. Important to remember that the volume of a gas is the volume of its container. Remember that gases will always take up any amount of space that they're given. Even if I only had one lonely gas particle in this large container, it's going to move around and take up the whole container. So the volume of that gas is actually going to be the volume of this container. Let's pretend it was 2 liters. We normally measure volume in liters, which of course is a capital L. And really the only major conversion that we have to remember is that it is 1,000 milliliters for 1 liter. So for example, if I had 3,500 milliliters of nitrogen gas, I could quickly convert that to 3.5 liters. And then my V would equal 3.5 liters. Okay, milliliters cancels with milliliters. I guess the other thing I could mention is that 1 milliliter is the same as 1 centimeter cubed. That doesn't come up a ton, but in case you ever saw something like 3,500 centimeters cubed, you could know that that means 3,500 milliliters. Those units are the same, centimeters cubed and milliliters. If you watch any of those medical shows on TV, you know they always say, give them 5 cc's of whatever medicine. Cc's is cubic centimeters, which is centimeters cubed. So that's just another way of saying give them 5 milliliters of a certain medicine. Okay, so that's it for volume. Pretty straightforward. Again, amount is always measured in moles, and volume is always going to be measured in liters. So we're going to switch colors here and move on to temperature. Okay, so we learned yesterday that temperature is a measure of kinetic energy. So how temperature works is the higher the temperature, the higher the kinetic energy, of course, which is the energy of motion. So temperature is a measure of kinetic energy. That's important to know. But in terms of actually measuring temperature, you guys know that we use a thermometer to do that. And you know that we normally measure temperature in degrees Fahrenheit or degrees Celsius. Okay? And you might even know that in science, we really focus on degrees Celsius, which is the metric unit. So Fahrenheit is what we use in the United States, for example, every day when we report our weather. But in science, we always use the Celsius scale. And the Celsius scale is based on water, where 0 degrees Celsius is when water freezes, and 100 degrees Celsius is when water boils. The thing about both the Fahrenheit scale and the Celsius scale is that both of these scales go negative. So you know that in Chicago in the winter, we have days where it's negative 30 Fahrenheit, right? And the Celsius scale goes negative anytime we're below freezing. So most of the winter in Chicago is below 0 on the Celsius scale. So we use the Fahrenheit and Celsius scales, but one thing about both of those scales is that they go negative. And so when we are making gas calculations, actually, it isn't convenient for us to have a temperature measured in a negative value, because when we have that negative and we start plugging into equations and stuff, it doesn't work out super well for us, because then we end up calculating, for example, a negative volume, which wouldn't be possible. So actually in gases, the temperature is measured in a new scale that you're probably not aware of. So when working with gases, temperature is measured in Kelvin, which is represented with a capital K. Now, interestingly, temperature is measured in Kelvin. That's not degrees Kelvin. So it's degrees Fahrenheit and degrees Celsius. But when we give a temperature in Kelvin, we don't say the word degrees. We just say Kelvin. Okay. And the thing about the Kelvin temperature is that the Kelvin scale never goes negative. So the temperature 0 Kelvin, that says 0 Kelvin, not okay. The temperature 0 Kelvin is what we call absolute zero. That is theoretically the lowest possible temperature. Remember that temperature is a measure of kinetic energy. So what scientists assume is that at 0 K, the temperature is so low that molecules would actually stop moving if we went any lower than that, because the kinetic energy would be so low. So Kelvin never goes negative. 0 Kelvin is the lowest possible temperature, and that's absolute zero. We cannot really achieve that in our lab or something. You would have to have a super high-tech lab, and for most people, that's a theoretical temperature, not a temperature we actually get to. So the Kelvin scale is what we're going to use today. But you know that our thermometers don't actually use or don't actually measure in Kelvin. So how are we going to get these Kelvin temperatures if the thermometers in our classroom don't measure in Kelvin? So how can we convert to Kelvin? It's super easy, actually. All we need to do is go from Celsius to Kelvin, and we're going to use these equations to convert temperatures. We're going to use this equation. So a lot of students find those equations really confusing, and they're really worried about this, but it's actually super easy. Let me explain. Here's how you read this first equation. If you want the temperature in Kelvin, you take the temperature in Celsius and add 273. That's it. So if you want to get the temperature in Kelvin, you just take the temperature in Celsius and you add 273. It's always 273. You don't have to think about that. You just always add 273 to a Celsius and you'll make it into Kelvin. The temperature in Celsius is always the temperature in Kelvin minus 273. So basically, if you're given Celsius, add 273 and it becomes Kelvin. If you're given Kelvin, subtract 273 and it becomes Celsius. So let's do a couple examples. Like if someone said 50 degrees Celsius, how many Kelvin is it? Well, I'm just going to say 50 plus 273, and that's going to be, I don't know why I need to use a calculator, 323 Kelvin. Cool. Let's say someone said 303 Kelvin. How many Celsius is that? I'm going to take 303, subtract 273. Again, it's always going to be 273. and that's 30 Kelvin. Okay, let's say we're below freezing, so it's -4 degrees Celsius. No problem. -4, that's a Celsius, so I'm adding 273 to make it Kelvin. -4 plus 273 is just going to be 269 Kelvin. Easy as that. Some students say then, oh, Ms. Ula, what if they give us Fahrenheit? Well, since we're talking about science, they aren't ever going to give us Fahrenheit because all scientists use the metric system, which is Celsius. So if we needed to convert from Fahrenheit to Kelvin, what we would do is first convert Fahrenheit to Celsius and then Celsius to Kelvin. But you guys don't need to be able to do that because our temperatures will always be given to us in Celsius or in Kelvin. But it is really, really important to remember that all gas calculations, I actually will write that because it's so important. All gas calculations must be done in Kelvin. Okay? Very often students do problems incorrectly and they review their work. Miss Ula, I can't figure out what I did wrong. And it's that they forgot to convert to Kelvin. They did the problem in Celsius. So whenever you're given a temperature in any gas problem, your first step should be to convert your Celsius into Kelvin by adding 273. Oh, one last thing I think I forgot to measure, super easy. Temperature, of course, is represented with a capital T. Lowercase t represents time, so we'll always use a capital T for temperature. All right, awesome. So we're on to our last one. Let's go ahead and go orange for that. So we talked about amount being measured in moles, volume always being measured in liters, temperature always being measured in Kelvin. And now we're on to the last one, which is pressure. So we learned that gases are able to exert pressure. Pressure is represented with a capital P. I'm not sure if lowercase p is something different, but for now we're going to just use our capital P. And the thing with pressure is it isn't quite as straightforward as the other properties because pressure can be measured in many different units. So it's not universal. Everyone measures the amount of a gas in moles. Everyone measures the the volume of a gas in liters. Everyone measures the temperature of a gas in Kelvin. But with pressure, we have many different units. So I've written, we have many different units of pressure that are used, which means essentially we have to be able to convert from one unit to another. So let's take a look at how we can do that. We have what we call our line of conversions. Okay, so we know that 1 ATM equals 101.3 kPa, which equals 760 torr, which equals 760 mmHg, which equals 14.7 pounds per square inch. Okay, so let's just break this down a little bit, okay? ATM stands for atmospheres, and that's a unit of pressure. So 1 atmosphere, 2 atmosphere, 3 atmospheres. kPa stands for kilopascals, and again, unit of pressure. 200 kPa, 300 kPa, 400 kilopascals. So that's another unit of pressure. Torr, we just say torr, so nothing to talk about there, and it is a unit of pressure. mmHg stands for millimeters, mm is millimeters, of mercury. And mercury as an Hg, the element on the periodic table. Now, mmHg, millimeters of mercury, and torr are actually the same unit. There's just some disagreement about what we should call it. Millimeters of mercury makes sense because the instruments we use to measure pressure have mercury in them. Torr, I believe, is named after a person, so maybe the person who came up with the system. And so torr and millimeters of mercury are actually the same. You'll notice both say 760. There's just disagreement about which to use, so people use them all. And then I just threw this one in. We won't really use this in science, but this is pounds per square inch. And I only threw that in because you might come across that in your life, because in the American system of measurements, we use pounds per square inch. It's not a metric unit, so we don't use it in science. But I just thought it would be interesting there. And so basically, if we want to make a conversion, we use this line of conversions. I'll show you how. One thing I want to point out to you is this line of conversions is not a mole map. If I'm converting from ATM to torr, I do not need to go ATM to kPa to torr. I don't need to make this a two-step problem because these are all equalities. They're all equal to each other. So I do not need to use this like a mole map. If I have two things in this line of conversion, I can just go ahead and do a one-step problem. Let me show you. Let's say I asked you for 350 torr. How many ATM is that? I see that both torr and ATM are in my line of conversions, and therefore this is just going to be a one-step problem. 350 torr. I know I want torr on the bottom, and I'm going to ATM. To fill in the numbers, I just look at my line of conversions. 1 ATM is 760 torr. Done. Now I'm just going to do 350 divided by 760. Boom. 0.5 ATM. Done. Let me do another one here. Let's say I had 2.6 ATM and I wanted to convert that to kPa. Just start with the number in the problem, 2.6 ATM. Both ATM and kPa are in my line of conversion. It's going to be one-step problem. Cancel out ATM. Going to kPa. Check my line of conversion. 1 ATM is 101.3 kPa. Cool. Plugging it into my calculator, I get 263.4 kPa. Done. Okay. Now we have a few more conversions that are not in our line of conversion. So, for example, we also need to know that 1,000 pascals is 1 kilopascal, and that 100,000 pascals is 1 bar. So if we're given kilopascals or bar, then we might need to do a 2 or 3 step problem. Let me show you what I mean. Okay, let's say I said we have 4,000 pascals. How many millimeters of mercury is this? Okay, I noticed that pascals is not on my original line of conversions. So I know this is a multiple step problem. So I'm going to say, okay, shoot, what do I know about pascals? 4,000 pascals. Well, I know Pascal has to go on bottom. I could convert Pascal to bar, but bar is not on my line of conversion. Ooh, I can convert Pascal to kPa. Because if I say 1,000 pascals is 1 kPa, now I'm in my line of conversion where I know 101.3 kPa is 760 mmHg. I got that from up here, line of conversion, 101.3 kPa is 760 mmHg. So again, I took pascals to kilopascals since kilopascals is in my line of conversion. Cool, just throw this in. So I'm doing 4,000 divided by 1,000 times 760, and I get 30400 mmHg. Oops, I didn't actually finish this problem. That is not the correct answer. Let me type it in right on my calculator. 4,000 times 1 divided by 1,000 times 760 divided by 101.3. Now I get the correct answer, which is 30.0 mmHg. Let me just plug that in one more time to make sure I did it right. 4,000 times 1 divided by 1,000 times 760 divided by 101.3. Boom, 30.0 mmHg. Okay, so that's how you do these problems. Now, I did really quickly want to show you how to do a problem like that on your Chromebook so that when you do your homework, you can type it in. So let me just go ahead and see if I can open up a Google Doc. I think we're still going. Is my video still working? Yep, my video is still working. So I'm going to do this, and I'm just going to say new document. Okay, so for example, in your homework, let's say you needed to solve a problem. I can't remember one of the ones we did. Let's say we did 40 kPa is how many mmHg. Okay, remember that you're going to want to do this insert equation piece, and then you'll get this equation line up here. Okay, now you're just going to say 40 kPa, and then you're going to use the equation things to do times. And then I want that fraction because I want to show my factor label method. So I come up here and I hit this fraction button right here. And it allows me to type on top. So in this case, it's going to be 760 mmHg. And then to get to the bottom of the equation, I just use my mouse and I use the cursor and I click to the bottom. Hopefully it's going to work. Click to the bottom of my equation. Let's see if it did. There we go. And that is 101.3 kPa. Okay. And then I can just get out of this equation right now and hit equals. And then I can type this into my calculator. 40 times 760 divided by 101.3. And I'll get 300.1 kPa as my answer. And maybe I'm going to do something. Serena, please stop making that noise. I'm going to do something like this to highlight my answer. So that's going to be really useful when you're making these conversions on your homework today. Okay, I hope you have an awesome day. Can't really figure out how to end my video, but I'm going to work on that. All right, have a great day, you guys, and we will see you later. Hopefully, if I ever end my video.
Pause it.
I can't figure out how to.
But you ended your video.
I hope it didn't end. It was here and I can't really figure it out. Recorder is recording.